It feels like AI just exploded out of nowhere, right? One minute we had clunky chatbots, and the next we have tools like ChatGPT and Gemini that feel like magic. But this overnight revolution wasn't overnight at all. It was kicked off by a single brilliant idea laid out in one research paper. So let's pull back the curtain and decode the 11 pages that truly sparked the AI.
It's the question everyone's asking. How did we get here so fast? What was the secret sauce that took AI from a niche academic field to something that can write code, create stunning art, and hold a real conversation? What was that spark? Believe it or not, the answer is right here. A research paper from Google with the slightly strange title, "Attention is All You Need." Now, these pages didn't just suggest a small improvement on the old way of doing things. They basically threw the old rulebook out the window. This was the big bang moment for modern AI. Now, to really get why this paper was such a huge deal, we need to take a quick step back. Let's look at the world of AI before 2017, because they were stuck on a really big problem. Before this paper, the top models, called recurrent neural networks, or RNNs, had to read sequentially. That means one word at a time. Imagine trying to understand a complex story by looking at it through a tiny peephole. You'd have to remember every single word that came before just to make sense of the current one. That's exactly what AI was up against.
And as you can imagine, this one word at a time process was a massive bottleneck. It was just fundamentally slow. And you couldn't just throw more powerful computers at it to make it go faster, because the process itself couldn't be sped up. It was like a traffic jam baked into the system.
But the real killer? It was short-term memory. I mean, look at this sentence. By the time the old AI got all the way to the word tired, it had often completely forgotten that the sentence was about the cat in the first place. The context just vanished over long distances. And if you can't remember the beginning of a sentence, how can you ever understand complex ideas?
So how do you solve a problem that big? Well, the authors of this paper didn't just propose a little tweak. They came in with something completely radical. They basically said, forget the peephole. Let's throw that entire one word at a time method in the trash. Their new model, which they called the transformer, was designed to process the entire sentence all at once. It could see the whole picture from the get-go.
Okay, but how does that even work? How do you read a whole sentence at once without getting totally confused? This was their magic trick, a mechanism called self-attention. Take this sentence. The animal didn't cross the street because it was too tired. We know it refers to the animal, but for a computer, that's a tough puzzle. Self-attention lets the model look at it and then score its relevance to every other word in the sentence, and bam! It sees a strong connection back to animal. It figures out the context by seeing how everything is connected.
And the best part, the engine behind all this was just some really elegant math. It basically boils down to matrix multiplication, which is something that modern GPUs, the graphics cards that power video games, are incredibly good at. So their solution wasn't just brilliant, it was perfectly designed for the computers we already had.
But they didn't stop there. They realized that paying attention to one thing wasn't enough, so they created multi-head attention. The perfect analogy is a cocktail party. You're not just listening to one conversation, right? You're picking up on different things at the same time. The words someone is saying, their tone of voice, what another group is laughing about. This lets the AI build up a much richer, more layered understanding of the language.
Now, you might be wondering, if you look at all the words at once, how do you know their order? To a computer, the dog bit the man and the man bit the dog could just look like the same bag of words. Their solution was so clever. Positional encodings. It's like stamping every single word with a unique mathematical timestamp based on its position. This gives the AI a sense of grammar and sequence without needing to read word by word.
So this new architecture wasn't just a little smarter, it was a total game changer. And it all came down to one thing: pure, unbelievable speed.
This slide just says it all perfectly. The old way was like being stuck on a single-lane country road. The transformer, because it could do everything at once, was like a massive multi-lane superhighway. It completely unlocked the parallel processing power of modern hardware.
And the results were just staggering. The paper reports they trained their largest model in only 3.5 days on just 8 GPUs. What used to take weeks, even months, could now be done over a long weekend. This incredible speed-up didn't just make training faster, it made building today's enormous AI models possible in the first place.
So it was faster, but was it actually better? Oh yeah. As you can see from this chart, the transformer didn't just meet the old benchmarks for things like language translation, it smashed them. It set a brand new state-of-the-art, blowing past even the most complicated older models.
The impact was immediate, and it was huge. This wasn't just some interesting academic paper. It was the starting pistol for the AI that you and I use every single day.
And you can literally draw a straight line from this paper to today's tech. The transformer architecture is the direct ancestor, the blueprint for pretty much every major AI model that came after it. BERT, which powers Google Search, GPT, the brain behind ChatGPT. Every single time you use one of these tools, you're using a direct intellectual descendant of this paper.
And what's really incredible is that the authors knew how big this was. In the final paragraph of the paper, they literally say they plan to apply this same idea to images, audio, and video. And today, AI image generators like Stable Diffusion and video generators like Sora are built on these exact same principles. They saw the future coming.
So, when you boil it all down, the evolutionary leap was this simple. We went from teaching computers to read through a tiny peephole, one painful word at a time, to teaching them how to read the whole page, or even the whole library, all at once.
It is no exaggeration to say that the blueprint for the entire AI revolution we're living through was written in these 11 pages. It was a simple, elegant idea that finally allowed AI to pay attention to the whole picture, and in doing so, it changed our world forever.